Hi there. With 18.2, we are talking about variation. What variation is? It's how a value is going to vary in relationship with a given constant. The first kind of variation we're going to talk about is going to be direct variation. Now, we say that y varies directly as x if y is equal to k times x, where k is what we call the constant of proportionality. Now, the other wording you might hear is instead of varies directly, you might also hear it referred to as directly proportional. So either y varies directly or it's directly proportional. We're going to take that y equals, and then you can notice that with the constant in our x, we multiply them together. Direct variation is when the constant's being multiplied with the x. What we're going to do with the first three examples is set up our direct variation equations. So the first one, the circumference c of a circle varies directly as the radius r. So we start with c equals, then we always have to have a k over here as that constant. So then we need to think, what operation do we have to use? Well, if it varies directly, we know we have to multiply by our r. Okay, number two, the weight W of a body varies directly as its mass m. So we have the weight of a body equals the constant, and it varies directly, so we're going to multiply by the mass m. Okay, I want you to pause the video and try number three. We have in a given wire, the electrical resistance R varies directly as the wire's length L. So we start with this capital R here. Also keep in mind you use capital letters if they are given to you, lowercase if they are given to you. So the electrical resistance R equals our K, and it varies directly, so we multiply by the length of the wire, L. The second kind of variation that we are going to be looking at is what we call inverse variation. We say that y varies inversely as x if y equals k divided by x, where k is the constant of proportionality. So here it's going to be set up very similar, but instead of the k being multiplied by our x, here they're being divided. So that's what we have to look at here. So example 4, Boyle's law states that at a given temperature, the pressure P of an ideal gas varies inversely as the volume V. So just like the other problems, we start with the first variable to give us, the pressure P equals, and then put your constant there. And then it says it varies inversely, which means we have to divide by the volume V. Okay, now pause the video and try number 5. For this one, it says a company finds that the number N of units of a product that are sold is inversely proportional to the square of the price P of the product. So here we have that word proportional again, just like we talked about in the beginning, that if it said directly proportional, that would be multiplication. Now we're talking about inversely proportional, which would be the division of the square of the price of P. So we have N equals the K. Since it's inversely proportional, we divide it by the square of P. So we have to do P squared. That would be our equation for that one. Now, the third kind that we're going to be talking about is what we call joint variation. What joint variation is that we say that y varies jointly as x and z if y equals k times x times z. So it's very similar to direct variation, but now we're joining two things together and multiplying them with our k. So example 6 is the cost C of a piece of sheet metal varies jointly as the area A of the piece and the cost C per unit area. So we're going to start with the cost C is equal to, start with your constant, and it varies jointly as the area A of the piece and the cost C per unit. So it's a capital C equals K times capital A times a lowercase c. The last note here, it says direct, inverse, and joint variations may all be combined. And we're going to see an example of that on the next page. So the example here, Newton's universal law of gravitation can be stated as follows. The force F of gravitation between two objects varies jointly as the masses m sub 1 and m sub 2 of the objects, and inversely as the square of the distance r between their centers. What I want you to do is pause the video and see if you can figure out what this equation would be. Okay, so we find F is equal to K times m sub 1 times m sub 2 divided by r squared. And we get that because it tells us the force F of gravitation between two objects. We start with F equals K. So I always start with my constant. It says it varies jointly, so we think multiplication between these two masses. So we're multiplying these two masses by the constant, and then inversely, so we know we have to divide by the square of the distance r, which would be r squared. So now what we're going to be doing is using these equations that we set up to find the value of k, and then taking it a step further to find whatever the isolated variable is. So let's go ahead and look at an example here. Example 8, if y varies inversely as x, and x is 15 when y is 4, we want to find the value of y when x is 12. So the first thing we have to do is set up our equation. So step 1 is going to be set up equation. And we can see here that with this equation, it says y varies inversely as x, which means it's going to be y equals k, so start with that, and it's varying inversely, which means we want to divide by x. So that's our first step. The second step is going to be solve for our k. So step 2, we are going to solve for the k. Now, in order to solve by the k here, we need to substitute a value in for y and x. Well, your problem will give you a y and an x that together they will give us our k. So then what we're going to do is take these two values here. Let's circle them in yellow. We're going to take these two values here and use them to solve for our k. So I'm going to put just like a line here so we can separate this. So now we want to solve for our k. So we have y is 4 equals k over 15. Now there's a couple ways we can solve this. You can clear your fractions, or you could even cross multiply. I know that in order to clear fractions, I'd have to multiply both sides by 15. Well, when I multiply both sides by 15, these ones will cancel. I'm left with a k on the right, and 15 times 4 we know is going to be 60. So there we have our k. So now the last step is going to be to use our k and the other value they give us to find our y. And again, the last step we're always solving for the variable that was originally isolated. So step 3 is going to use the value of k to finish the problem or to solve for the y in this case. So now I'm going to draw another line to separate this and set up our equation. We're solving for y, so we're going to let it be y equals our k, which is 60, over our x, which is now we're going to use the value of 12 because we want to find the value of y when x is 12. And then the only thing we have to do here is divide. 60 divided by 12 is y equals 5. So this would be our final answer because we found the value of y when our x was 12. Okay, so now let's look at this next one. Example 9. The frequency f of vibration of a wire varies directly as the square root of the tension T of the wire. If F equals 420 Hertz when T is equal to 1.14 newtons, Find F when T is equal to 3.40 newtons. So again, we're going to follow these same 3 steps here. So step 1, you're going to set up the equation. So what I want you to do is pause the video and set up your equation first. Okay, so our step 1 was to set up the equation. The frequency F, so we start with the frequency of F equals K, and it varies directly, so it's multiplied by the square root of T. So there's our first step. Step 2 is to solve for K. So if we want to solve for K, we have to know what the F and the T is, which is what we know right here. If F equals this when T equals that. So step 2 is going to be solve for K. So now we're going to say 420 equals K times the square root of 1.14. So again, step 2, just like above, is solve for K. Now, in order to solve for K here, the only thing we have to do is divide this. So when we divide both sides by the square root, we're getting K is equal to 420 divided by the square root of 1.14. Now, I'm going to leave the value just like that because just like we've talked about in all of our other problems, we never, ever, ever want to round until the very end. So I'm just going to leave that as my K, and I'm going to store that into my calculator. So I'm going to get my fraction and type 420 divided by the square root of 1.14. And then I'm going to store that whole thing as alpha k, which is above the 8. Now, step 3, just like we saw in the previous one, this one was to solve for y, but here the problem's saying we want to find our f. Well, in order to find our f, we have to let that be equal to our k, which is what we know, this 420, divided by the square root of 1.14. And we need to multiply by the square root of t, which it tells us that the t is, in this case, is going to be 3.40. So we're multiplying this by the square root of 3.40. Now I'm going to type this whole thing into my calculator at once. And when I do that, I'm getting f is equal to 725.33, and it continues on from there. Now, since we're finding an f, the rule of thumb that we use, and I will be very specific about this on the exam, if we go back to the original measurement of our frequency, we can see that we have 2 sig digs. So typically we'd round this to 2 sig digs. Well, 2 sig digs here, we'd be looking at these first two, but since the number to the right of the 2 is a 5, that bumps that 2 up to a 3. So our adjusted answer would be 7, 3, and then we have to put the 0 here. And we're finding a frequency, which would be hertz. So 730 hertz would be our F when T is equal to 3.4. Again, step 3 of this, just like we looked at before. So step 3 was to solve for, in this case, would be the F. These take a little bit of practice to get used to. What I would encourage you to do is after you take the notes here, rewatch it again and just watch, listen, try out the homework, reach out if you have any questions. Thank you.